This video covers the Detour input component of Part B of the MiPACE training series. We will review how the detour route is represented in MiPACE and how the route segment and intersection inputs are defined before the model is computed. Detour input applies to freeway facilities only. This section is used when the freeway analysis includes an alternative route for traffic that may be diverted away from the main line. The detour input is used to model the geometric and basic roadway characteristics of the alternative route. The screen is organized in 3 numbered sections: the detour layout, the detour segment table, and the detour intersection table. On the left, the detour input table contains 4 setup inputs: the number of detour intersection, the existing detour street ADT and detour road type, and the freeway off-ramp used by the detour. We'll go through these sections in order. The detour layout is a conceptual representation of how the route is connected. It is not intended to be a map to scale. The black line represents the freeway mainline corridor, while the gray line represents the detour corridor. The numbered cycles identify the detour intersections. Traffic leaves the freeway through the selected off-ramp. It travels along the detour streets through the modeled intersections and cross streets, and then returns to the freeway through the downstream on-ramp. The off-ramp and on-ramp locations are established from the freeway geometry defined in the geometric input. The dual segment table defines the roadway section that connects the numbered nodes and intersection along the detour route. For each segment, enter the segment length in feet and a posted speed in miles per hour. As the values are entered, they are reflected in the layout above. Segment lengths are shown in red font and posted speeds are shown in dark blue. This provides a quick visual check that the coded route matches the intended detour geometry. The segment includes the connections from the freeway off-ramp to the first intersection and the roadway section between intersections and the final connection back to the on-ramp. Detour intersections table defines the individual intersections that the evaded traffic enters along the detour ramp. The number of active intersection columns corresponds to the number of detour intersections specified in the detour input table. For each intersection, enter the control type, number of lanes, whether the detour approaches stop control where applicable, the number of detour street lanes, the number of cross street lanes, and the movement made by the diverted traffic. This input describes how the detour path passes through each intersection and provides the intersection characteristics used in the analysis. The detour input table on the left establishes the route setup before the individual intersections are coded. The number of detour intersections determines how many intersections columns are used in the detour intersection table, while the detour route type identifies the roadway classification of the detour corridor. The remaining route level inputs as existing detour street, ADT, and the detour off-ramp are discussed next. Existing detour street ADT represents the average annual daily traffic, already using the detour roadway under normal conditions before any work zone condition is added. This value should be obtained from an appropriate traffic count or agency data source, such as the m.adt map. If the available ADT values vary along the detour route, like in the example, the analyst should select the value that best represents the modeled detour segment or corridor. The detour off-ramp identifies the freeway off-ramp where diverted traffic leaves the main line and enters the detour route. The field is a drop-down list populated from the off-ramp segments that were modeled earlier in the geometric input. Select the off-ramp that corresponds to the beginning of the intended detour. The red arrow in the example illustrates where that selected off-ramp connects the freeway to the detour. The intersection-related inputs are used to represent the operating conditions at each detour intersection and to estimate the delay experienced as diverted traffic moves through the route. This example shows intersection 1. It is modeled as a two-way stop-controlled, three-legged intersection. The detour approach is stop-controlled, the detour street has one approach lane, the cross street has one lane, and diverted vehicles make a left turn movement. The same set of fields is completed for each remaining intersection using its actual geometry and control condition. Once the detour route inputs have been reviewed, the model can be computed. This completes the training part covering the global input, geometric input, demand input, and detour input. Part C will focus on the results and output. Thank you.